On the screen now is the file that I have asked everyone to download and study the patterns. So I take it that you have already downloaded and already have identified the patterns that is displayed here between a number and its square. As you can see, there are 28 tables here on this page, and each table represents a number and its square. So what are the patterns that you have already recorded? So let's compare our notes. The first pattern that I want to highlight here is the last digit of the square. If you can see the whole stretch of each row, just take a look at the last digit of the square number. They're all 0 here. 0, 0 here, 0 here, everywhere is 0. Everywhere. Now take a look at the second line. The second line, they are all 1. 1, 1, 1, everything's 1. Just take a look at the last digit of the square number. What about the third row? They're all 4. No, if I go to the third row of other tables, there are also 4. They're all the same. Just take a look at everywhere there. The last digits are always the same whenever the number that before it's being squared are 2. If it's 2, the last digit of the square are 4. Now let's take a look at more observations here. What about the fourth line? It is 9 when it is 3. The square is 9 when the number is 3. And everywhere is 9. Everywhere. Just pick any of the table here. Take a look at the fourth row. And the last digit of the origin number is 3. Then the square becomes 9. Now let's take a look at the next line. The next line, the original number is 4. And the last digit of the square is 6. And you can see everything consistent. So this is the first pattern. Yeah, the last digit is 4, but the square last digit is 6. Everywhere. Consistent. What's next? The next line. When the last digit is 5, then the last digit of the square is also 5. And it's true everywhere. Everywhere. Consistently. Let's take a look at the next line. I think you get the picture. When the last digit of the number is 6, then the last digit of the square is also 6. And it's true everywhere. 6 here is true everywhere. Everywhere. I don't need to go and highlight all the numbers there. I think you get the message. The next line, when the number is 7, the square is always 9. The last digit is always 9. And you can see all row that has the last digit of 7, the square is always 9. You can verify it by yourself. Next is line with 8, the last digit of 8. And the square last digit is 4. And finally, when the last digit of the number is 9, and the square is always 1. Always 1. So that is the first pattern that I would like to highlight here. I hope you have already identified that pattern as well. So the last digit of the squared number are consistent with the last digit of the original number, of the, what shall I say, pre-squared, before it's been squared. Okay, that is the first pattern that you should have identified. So what would be the next pattern? It is still about the last digit of the square number, but I would like to highlight the repeatability. Take a look at the first table here. And they are also true with all other tables. The middle one is 5. Maybe I should choose a different color. This is like the middle of the pattern, and you can see it is repeated. The last digit is 6, and then over here is 9, and then the last digit here is 4, and then here is 1. And what about 0 here? 0 also have a pair here. So let's see, if I extend this table to become 10, then it becomes 100. The square of 10 is 100. So it is repeatable. It is as if it is a mirror image when the mirror is placed at 25 here, or at 5 and 25 here. And it is true for all other tables as well. So that is the second pattern that I would like you to know. So let's update our observation. The last digit of the square number have repeatable pattern. Okay, next. Let me just delete all the notes here. As you can see, I have already color-coded this table. And why do I do that? Because I want you to identify the next pattern. Take a look at the number of groups, the number of paired groups in the squared number. If you notice, we have two blues here, or let me just choose a different table. Let me just choose this one here, right here. Okay, we have pair of blue and pair of red, blue here and red here. So as you can see, there are 4 groups, 4 pairs of numbers, 4 pairs of digits on the square, and that corresponds to the number of digits of the number before it's being squared. So that is 4 pair, over here 4 digits. So that is the second pattern. You can check the other tables as well. They are consistent. Over here we have 3 pairs, and over here we have 3 numbers, 3 digits. And take a look at this one. 3 pairs, and the last pair, the leftmost pair, is a single pair, and it has 3 digits. True for this one as well. 2 pair, and the leftmost pair is a single pair, and that corresponds to the number of digits of the number of its square root, or before it's being squared. So that is the next observation. Let's update our list. The number of digits in the square root number is equal to the number of paired groups in the squared numbers. Okay, that is the third observation. Now, the fourth is the last observation that I want to note down. You might find other patterns, but if you do, then you might want to share with me the other patterns that you have observed by sending me questions in the Udemy menu. Okay, the last one that I would like to highlight is the leftmost digit. The leftmost digit of the square versus the leftmost digit of the pre-squared, of the square root number. Let's just randomly pick some components, some rows here. Okay, I'm picking this one, picking this, this, and this. And now compare the leftmost digit of the square root on the left, and then with the leftmost pair on the right after it's being squared. Let's pick up the first one. Let's pick up this one. What is the leftmost digit on the left? It is 6, and the leftmost digit on the right is 36. Yes, 36 is 6 squared. It is basically equal. 6 squared is basically 36. Now let's take a look at the next example. This one. The leftmost is 3 versus 9. So what is your observation? Yes, 3 squared is equal to 9. As you can see, the other groups as well correspond to the same pattern. Square root of 8 is 64, square root of 5 is 25, square root of 7 is 49. And I want to pick up a different row now. The point I'm making is not exactly that they are square root, but it is either less or equal to the square root. And take a look at this one. The leftmost digit is 2, and the leftmost pair is 6. As you can see, 2 squared is equal to 4, and 2 squared is less than 6. It can be either less than or equal to, but it never exceed. Pick up another one at random. This one. What is the leftmost digit on the left? The leftmost digit before it's been squared is 5, and the leftmost pair is 33. And 5 squared is less than 33 because 5 squared is equal to 25. If you scour the whole table here, you will not find any single one that exceeds the leftmost pair after it's been squared. It only less or equal to. So that is the final pattern that I would like to note down. The leftmost pair of the square number are greater or equal to the square of the first digit of the square root number. So now that you have already identified these patterns, so it is time for us to use our knowledge about square into use in the next few examples. So that will make sure that we are able to square or square root the numbers speedily. So all the best to you, and see you in the next video.